Acids and bases. So acids and bases, when we first look at them, we first got to take a look at the nature of water. So water is two hydrogens and one oxygen, and water undergoes a constant dissociation into ions. So it actually forms hydronium, H3O plus, and OH minus hydroxide. And when we look at acids, these are things that will increase the hydronium ion concentration. So when placed in water, they'll shift the equilibrium so that there's more H3O plus than OH minus. In water, they're the equal amounts. Acids have a sour taste, react with metals, and are found in a lot of foods. So citric fruits, vinegar, apples, grapes, all have different types of acid in them. There's also acid in our stomach, gastric acid. Bases are substances that actually increase the hydroxide, OH minus concentration in water. They have a bitter taste. They're very slick. If you ever feel bleach, it's very slick or slippery. Found in a lot of cleaners, so sodium hydroxide is found in bleach. There are also antacids. Baking soda used to be an antacid. It has sodium bicarbonate, which is a base in it. And what we need to know, kind of is fun to know, is that ion for ion, they're more harmful to tissue than acid. So we see these pictures where women get acid thrown in their face, are attacked, especially models in other countries. It seems to be more prevalent, but bases actually are more destructive to living tissue. So when we talk about the strength of an acid or base, we need a scale. So they have this pH scale, goes from 0 to 14. Water is right in the middle at 7. Acids are to the left, 0 to 7. And bases are 7 to 14. There's actually acids that are much stronger, that go below 0, and there's some that go up to like minus 35. And these are the type of acids, and they're usually like biacids. They mix these two acids together, and they become even more stronger than they are individually. And they would like eat through metal, like in the movie Aliens. Something like this would eat right through metal. Another way to check acids' pHs, we can look at two things. We can use indicators. Those use color, like test strips or little vials that actually change color that give us a pH range. Some will tell if it's simply an acid or a base. Other ones will give us ranges like 1, 2, 3, 4, 5. But they don't give an exact pH. If we really want to know the exact pH of something, we have to use a meter, something like this. It has a little probe, and there's chemicals in the probe that actually let it tell you the exact pH. This one on this picture only goes to 2 significant decimal places, 7.00. The one I work at the lab goes actually to 3. So these use a little digital readout to give you an exact pH. So again, indicators use color to give you a range, and meters give you an exact pH using a little probe and a meter. Titration. So titration is a reaction that takes place between an acid and a base, and it produces water and a salt. So on the bottom there we can see sodium hydroxide plus HCl, hydrochloric acid, gives us sodium chloride, which is table salt, and water. Generally titrations are used to identify unknowns. If you look at the picture, they're trying to calculate the concentration of an unknown acid. So this would give us a pH or concentration of acid much more accurately than maybe a indicator would. This could give us a much more accurate reading of pH if we had an unknown concentration of base or acid and did a titration reaction. We're not going to talk too much about concentration, but concentration is the amount of a substance in a volume. And in terms of acid, sometimes we'll use molarity. That's moles of acid per liter of solution. Sometimes we'll use things like part per million of an acid, or we'll just use the simple pH. So there's varying ways to describe pH and the concentration of a solution. So acid rain, what is it? Acid rain is going to be any rain with a pH of 5.5 or less. Most of acid rain is formed due to sulfur oxide and nitrogen oxide emissions from burning fossil fuels. And it's really bad because it actually messes up the aluminum levels in lakes and so forth, and it's toxic to many aquatic species. Also, acid rain will degrade metal, so bridges, buildings get degraded from acid rain. Cars actually rust out from acid rain. So acid rain is a major issue, so there's been a lot of regulations put in place to limit the amount of emissions that fossil fuels can have. So they're limiting the sulfur in gasoline and nitrogen as well. So there's been a lot done to try to limit acid rain, and there's a lot of things we can do as individuals to help that.